An early human moves toward a fresh antelope carcass. There is still plenty of meat on it, but a big cat may have fed there first, and it may not be finished. Move in now, and you could get badly hurt. Wait, and the best food may disappear. So how did early humans compete with big predators for meat? Fight or run? That is the obvious choice. But nearly 2 million years later, the bones cannot tell us whether anyone charged a cat, shouted, or backed away. What they can sometimes tell us is something more useful. Who got access to the carcass first? A cut mark proves a hominin cut the bone. It does not prove the hominin killed the animal. A tooth mark proves a carnivore used the carcass too. It does not prove the carnivore got there first. So one mark cannot solve the encounter. Archaeologists have to combine several clues. Which bones are still there? How complete was the carcass? Where are the cut marks? Where are the tooth marks? How were the bones broken? And what kinds of patterns show up when humans and carnivores feed on carcasses in different orders? Even the location of a mark matters. If a carnivore had already stripped most of the meat from one part of the body, humans coming later would have fewer chances to leave meat-cutting marks there. But if humans got there first and cut meat from those same high-value areas, a later carnivore would be working with a very different carcass. Researchers compare those patterns with what they see in modern and experimental carcasses. The match is never perfect. Ancient feeding events weren't controlled experiments. Lions don't eat every carcass in exactly the same way. Neither do hyenas. Neither do humans. But these comparisons still give researchers something better than guesswork. They let us ask a much more useful question. If this sequence really happened, would we expect the bones to look like this? That's the key mechanism behind the whole story. Every consumer changes two things at once. It changes the food that's left. And it changes the evidence that the next consumer will leave behind. Now let's go to Kanjera South in Kenya, around 2 million years ago. What makes Kanjera important isn't one spectacular bone. Across several layers at the site, early hominins kept coming back to animal carcasses and cutting them up. Some bones have stone tool cut marks. Some were deliberately broken open. And many came from relatively small animals in the cattle and antelope family. So this wasn't just one lucky meal. Early humans were repeatedly getting access to animal foods. But here's the more important part. Many of those smaller animals seem to have reached humans while the carcasses were still fairly complete. That matters. If early humans had always waited until large carnivores were completely finished, we'd expect a different pattern. The first animal at a carcass usually takes some of the best tissue. It may also destroy bones, carry parts away, or leave only certain pieces behind. A late scavenger gets whatever survives that first round. But Kanjera often doesn't look like that. The small carcasses are relatively complete. The ages of those animals matter too. And so does the location of the cut marks. Taken together, the evidence supports the idea that humans often got access fairly early. Later studies that mapped where those marks appeared strengthened the same case. Humans were cutting meat from parts of the skeleton that would be harder to explain if a large carnivore had already stripped most of the carcass. And that gives us our first big change in the story. Early humans were not always stuck at the very end of the line, picking over whatever stronger predators had left behind. For some of the smaller animals at Kanjera, hunting is a strong explanation. But there's a catch. Early access is not the same thing as a witnessed kill. Those are not the same level of evidence. A fairly complete carcass can reach humans in more than one way. Maybe the humans killed the animal themselves. Maybe they found it soon after it died. Maybe they got access before another carnivore had done much damage. Different routes can leave humans with a carcass that still has a lot of food on it. So Kanjera lets us say much more than humans ate meat. It tells us they often got there early. For some small prey, hunting is a well-supported explanation. But we still can't say that every carcass humans reached early was an animal they had killed themselves. And that difference matters a lot when we move to Olduvai Gorge in Tanzania. At the famous FLK Zinj site, early humans were also processing animal bones roughly 1.8 million years ago. Researchers have argued for decades about what those bones tell us. Did humans get to the carcasses first? Did carnivores? Or did the answer change from one animal to another? Some studies suggest that humans got to at least some of the smaller animals early. Other researchers have questioned whether some tooth marks were identified correctly and how well the feeding experiments really match the ancient bones. And that disagreement teaches us something important. An archaeological bone is not a damaged video recording that we can somehow sharpen until one perfect story appears. Different events can sometimes leave similar traces. A lion doesn't strip exactly the same amount of meat from every carcass. A hyena doesn't damage every bone in the same way. Humans don't butcher every animal with exactly the same pattern either. So you can't count a few cut marks or tooth marks and expect every case to have one obvious answer. But another site at Olduvai gives us a much clearer case where the order flips. It's called DS, or David's site, and it dates to around 1.84 million years ago. There, researchers found an animal bone where the order seems much clearer. A large cat left its tooth damage on the carcass first. Then hominins cut it later. The animal was probably a lion or another large cat. The exact species is less important here than the order. Big cat first. Humans second. And now we have direct evidence that early humans sometimes scavenged carcasses that a major predator had already used. This is the point where the most dramatic version of the story becomes very tempting. A lion makes a kill. Early humans rush in. They shout, they throw stones, they force the cat back, then they cut off meat and get out before it returns. Could something like that have happened at some point? Possibly. Does this bone prove that happened? No. The bone gives us the order. It doesn't give us the encounter. Maybe the cat had already left. Maybe the humans waited at a distance. Maybe they moved in during a short opportunity. Or maybe there really was some kind of direct confrontation. The evidence can't tell us which one happened. And that distinction matters. Scavenging a carcass after a big cat used it is not the same thing as actively driving the cat away. Modern people in parts of Africa have sometimes taken meat from kills made by large carnivores. So we know that kind of behavior is possible. But that does not prove that hominins nearly 2 million years ago used the same tactic, with the same tools, or under the same conditions. So DS gives us a narrower answer. But it's a stronger one. A large cat could feed first, and humans could still get food from the carcass afterward. Then DS changes the story again. If that one carcass showed the normal pattern at the site, we might expect the rest of DS to look like repeated human scavenging from big cat kills. It doesn't. When researchers looked across the whole site, many of the tooth marks they could identify most confidently looked more like hyena damage. And much of that damage makes more sense if the hyenas arrived after humans had already processed the carcasses and left parts behind. Now the order has flipped. In that special felid case, the big cat came first, and humans came later. In many other cases, the human marks seem to come first, with carnivore damage added later. That gives us the second big shift. One carcass can prove that a behavior happened. It cannot prove that the behavior was the normal way of life. And this is where the old question starts to fall apart. Were early humans hunters? Or were they scavengers? That sounds like a simple choice. But it may be the wrong choice. Because a carcass keeps changing every time something feeds on it, it changes every time something feeds on it. The first animal or group to feed may get most of the meat, organs, fat, and intact bones. The next consumer may still get useful food. A later scavenger gets whatever is left after that. Different animals, different places, and different moments create completely different opportunities. So instead of asking, what were early humans? A better question is, where did they enter the carcass sequence in this particular event? B. When researchers compare several early sites, the bigger picture also argues against one simple idea, that early hominins mainly lived by stealing kills from large predators. Early humans clearly did scavenge when the opportunity came. DS shows that. But this is another distinction we have to keep. Evidence that something happened does not mean it was the main strategy. And that is the third big shift. The most dramatic behavior may have happened sometimes. That doesn't mean it explains the whole system. The easiest way to understand the larger pattern is to think of a carcass as a resource that keeps changing over time. At the start, there may be plenty of meat, organs, fat, and intact bones with marrow still inside. Then one consumer feeds. Now the carcass is different. Another consumer arrives. It changes again. By the time a later scavenger shows up, some foods are gone, some are still there, and the skeleton already carries traces from whoever came before. So, the order matters because the order changes both the reward and the risk. If humans arrive early, they may get more food. But that may also mean they killed the animal themselves, or that they are dealing with a carcass other predators have not yet fully abandoned. If they arrive later, getting access may be easier in some situations, but the carcass may already be partly used up. And if hyenas arrive after humans, then this time, the humans are the ones who got there first. They are now the ones deciding what the next scavenger gets. This is the piece that connects Kanjera and DS. At Kanjera, early hominins often seem to have reached small carcasses while there was still plenty of useful food left on them. For at least some of those animals, hunting is a strong explanation. At DS, we have at least one clear case going the other way. A large cat first, humans later. And across other remains at DS, hyenas often seem to have damaged bones after humans had already processed them. Put all of that together, and the biggest conclusion is not just early humans were flexible. That's too vague. The more specific point is this: early humans were not always the last ones to reach a carcass. Sometimes they got there early. At least sometimes, they came after a large predator. And sometimes other carnivores came after them. That's why a single label can be misleading. If early humans were only passive scavengers, Kanjera is hard to explain because they repeatedly seem to have reached valuable carcasses early. But if they were only hunters, the clear scavenging case at DS becomes hard to explain. And the idea that early humans mainly survived by constantly stealing fresh kills from powerful predators doesn't fit the overall pattern very well either. What we see instead is that the order changed from one carcass to another. And that also changes what it means to compete with big predators. Competition does not have to mean a face-to-face fight. Two species can compete simply because both want the same limited resource. If humans reach a carcass before hyenas, the hyenas get less. If a large cat feeds first, humans get a different and usually more depleted carcass. If humans get a small animal before other carnivores do, then for that carcass, they get first access to the richest food. So yes, this competition could involve physical danger. But it was also about timing. Who got access while the carcass still had enough food to be worth taking? Sometimes the bones can give us a surprisingly good answer. But this is also where we need to stop pushing the evidence too far. These sites do not prove that meat automatically made brains bigger. They do not prove that meat created human cooperation. They do not show that every early human group used the same strategy. And they definitely do not tell us exactly how many people walked up to a carcass, what they were carrying, how far away a predator was, or whether anyone shouted, charged, waited, or watched from cover. Those details are gone unless some other evidence preserves them. What the bones do tell us is already important. By around 2 million years ago, hominins were repeatedly processing animal foods. At Kanjera, they often seem to have reached carcasses before large carnivores had eaten away much of the available food. For some smaller prey, hunting is a strong interpretation. At DS, at least one animal had already been used by a large cat before humans later cut it. And in many other cases at DS, the evidence fits a different order better: humans first, hyenas later. So how did early humans compete with big predators for meat? As far as the evidence shows, they were not routinely charging lions and stealing their kills. Instead, humans could arrive at different stages, depending on the carcass and the situation. Sometimes they got valuable animal tissue early enough that other carnivores came later. Sometimes humans were the later ones. Their place in that sequence could change from one event to the next. And that's why these bones seem contradictory only if we force early humans into one permanent role: hunter, scavenger, kill thief. The evidence doesn't support one label all the time. It shows that who got there first could change from one carcass to the next. A cut mark can tell us a hominin was there. A tooth mark can tell us a carnivore was there too. But researchers can combine those marks with other clues: how complete the carcass was, which bones survived, and what kind of damage they carry. Then they can compare that pattern with tested models, and sometimes work out who probably got there first. They can't replay the confrontation. But they can tell us something more useful than the most dramatic version of the story. Early humans were not always waiting for the predators to finish. Sometimes the predators were the ones arriving after them.